Okay. Good evening. Again, we know how this goes when I do these in the evening. They're usually not that good. So, apologies. Again, these videos will get a lot better if anyone is actually watching them. Um, after my final on Monday. But anyways, it is day 15. Um, again, I'm just gonna do the advent of code today, see how far I can get on that. And then that's it. So that's probably gonna be this thing I'm gonna do today, tomorrow, and Monday, and then starting Tuesday we're gonna start a project. So, um, actually, you know what? Maybe I do Leetcode today and not advent of code because advent of code takes a lot of brain power, and when it's like at night and I've like I've already been through like a lot today, um, it doesn't usually go that well. So actually, now that I'm like rethinking it, I think because this one horrible, right? I mean, Advent of Code Day 13 went pretty bad. Had to GPT most of it. Didn't get to part two. I think I just like save this for next for when I'm completely free. So I think today I'm just gonna start some leak code work. So so what, like 2 to 3 leak codes today? I think that's pretty good. I think if I do 2 or 3 leak codes. Also, check this fucking. I got this from Walmart, bro. It's like a little green, like fucking. I don't know what you'd call these, but like it's kind of nice. It was like fucking $9. I like it. Anyway, anyways, um, neat code. We'll just work on this today. Um, yeah, trees. Isn't that fun? Invert a binary tree. Okay. Anything else I want to talk about before we do this? Um, for the chess thing that I'm doing for 335, which is my How Computers Work class, there's actually I can show you. Nope, not that. Um, okay, I have a flip phone. Okay, I think I went over that one on point. So the quality is fucking terrible. But so this is the thing I've been talking about for a couple weeks. So this is the little. It's like a 7 by 7 inch chessboard with like you've seen these 3D prints before, obviously if you've watched the videos. And so this electromagnet goes up and down. And so this is what I was running into is so the electromagnet comes on, it picks it up eventually, and then that happens, right? It only goes up this much. So like if I were to now move the arm, it would just wipe out all the chess pieces. So we're gonna have to cut down these chess pieces and then put um a bigger block inside of there. Because right now this is what happens is it's just it doesn't go up enough. So yeah. Um so anyways, so that's where I'm on with that. That's what I was working on this morning. And I'm gonna have to cut down all the pieces. Um, and then it should be good. Hopefully, maybe. We'll see. Anyways, um, okay. You're given the root of a binary tree root. Invert the binary tree and return its root. So 1, 2, 3, 4, 5, 6, 7, 1. These are flipped, and all of these are flipped. So this gets 2. Okay. So is this how binary trees are given? Is this just given as tree node? You have a value, and then you have a right, and you have a left for every value. So what is root? Can I just print root? Is root just like a no, it's a node. So print root dot value. Is it a linked list? It's not a linked list, right? 4. Whoa. Oh, yeah. Oh, what the fuck is that? Huh? What is this? Root equals 1, 2, 3, 4. Um, print root dot left. See how that works. Dot val. Sorry. 2. So this is just saying like up here is a 4 and then left is like a 2. Okay, I see. So but this is like can I do like a root dot left dot val? This would be like an index out of range error on some stuff, right? Dot left. So it would be like this and then to the left is this and then to the left is this. Yeah. Okay, so I don't think it's I mean, I guess it could still because you could do a dot next. What would like truly make sure that this is I guess it would be like if you wanted to do like a root at 2 dot val, if like this would say if this is a thing or not. I'm guessing that would never work though. Yeah. Okay, so think of it as a linked list. So I want this error out of here. Print yo. Okay. So we want the base case before I even think about anything. It's just if root um is none, return root. Does that settle this one? Yeah. Okay. Um. So how could we do this? So the top is never going to change, right? So what can we do? We can just say like new tree is equal to I mean, what do we do like what like tree node root dot val? And then can I print new tree dot val? Is that a valid syntax? Yeah. Um and so then if I did like a print new tree dot left, there should be nothing here. None. Okay, so I can do that. And then so what I want to do is if we go to like we want to go so it's what do they call it on a tree? The depth or whatever. So we want to go to a depth of 1 and we just want to switch the nodes. And then we go to a depth of 2, we switch the nodes. I mean, we literally just like want to go down a side and just keep switching all the nodes and then go all the way back and then go all the way back up to like the root or something and then go down like every single path and just switching all the nodes. Like for each node, for each level, switch, right? So like can you so like what would you say the length of a root is? Actually, is this a valid thing? I don't think it is. No. So so what? We want to like hmm. Well, actually, Oh, could this be a sliding window of sorts? No. God, this is an easy one. I feel like a fucking idiot for not already having this. Um, well, let's just take. It's just how do I keep track of like going down like the nodes? I don't get that at all. It's got to be a recursive thing, right? It has to be like I start here, right? And I say, switch dot left and dot right. And then just keep going down everywhere and just switching the left and the right for every given node. Like every single node, its left and right value just need a swap. It's like as simple as it is. But how do I code that? Just like while root dot left and root dot right, not none. But then it's like what? It's like root dot left or like temp left equals root dot left. Root dot left equals root dot. What am I hearing right now? What did I just hear? Am I going insane? I'm pausing and figuring out what I just heard. I've come to the conclusion that I don't know what I heard at all. That was weird. Anyways, root dot left equals root dot right. Root dot right equals temp left. Wait. Yeah. But then what do I fucking. Because now it's like, okay, I've now switched these. Okay, so like right now, if I then did say return root, right? I don't even need this. If I did this, right? Time limit exceeded. For what did it exceed? Oh, because. But there's no dot next. So how do I go down? How do I go down a tree? It's not like a link like the linked list has a dot. I mean, I guess this is a dot next. So what did I do on? Oh, I set it equal. I set root dot val. But would that not? I need to ask ChatGPT a question. I have a question for ChatGPT. Don't answer this. I fucking hate O1 Mini. Don't answer the actual problem, but how do I like go down this tree? like how do I check each node's left and right? Don't solve what I am trying to do. Just answer the direct question. First on a binary tree, use recursion or an iterative approach. Traverse. Wait, def traverse. So it is just a recursive thing where you do something and then you go down. Stack. Start the root node on the stack. Get the current node. Do something with it. If current dot right. I like recursion better here. So instead of doing this, I can just say like def def search tree, right? And I give through like a node. That what he did here? You don't have to define it. No way. If node is none, return. Else, and then what? In here, I just say search. Oh, wait, how would I even do this? I mean, I'd have to just pass through, like, it would be like search tree. Fuck off. Search tree, pass through the root. And so what would this do? It would just say, it would take the left and the right value. But I don't get how this is recursion. Oh, you keep referencing dot left, dot left, dot left. So, oh, I definitely could just do return tree equals tree node root. Call search tree on the root. Um, well, if node is none, we return. Otherwise, I just want to keep. I mean, it's going to be something like search tree node dot left, search tree node dot right, right? So it's like I want to swap these, and then I want to like go to the. I don't think this is because okay, we get through a node. Say we get through root first, and we take the temporary left, which is 2, and we say okay, this is equal. This is now 3, and now the right is equal to the temp left. So now this is effectively 3 and 2, and so now I take node dot left and node dot right, and I pass it through. Actually, maybe right, and then actually I don't even need this. Where do I even define this then? Do I do it in this? No, shot. What? I passed through 4. Does it actually want me to do this, you think? Oh, sorry. Well, actually, nope, same thing. Why? If node is none, just return, right? And eventually we should do that. So before I recursively call this, let me print off root dot left dot val and root dot right dot val. Node, node, node. Sorry. Node has no. What are you talking about? Six and six. What? What? 6 and 6. I don't get what the bug is, to be honest. Like why it's saying I can't do that. Okay. I still don't get how this would be fucking up. Wait. Oh my God. Was that just not the issue then? 9 and 6, but I have no idea what happened to the 1 and 3. If no, actually no. No, no, no. I should just be able to do this. No, other way around. No, actually this one's right. Wait, what did it do here then? Oh, it's an AFK tracker. Else, I got you. I got you. Else, none. Is what I want, right? Not the string none. What are you talking about? I'm so confused. Fine, I'll copy your fucking code. What changed? What changed? What changed? What even changed? What even changed? What even changed? Is this not my exact code that I already made? Temp left equals node dot left. Node dot left equals node dot right. Node dot right equals temp left. There's no way changing these to strings of none fixes this, correct? Okay, so I mean, actually, in this example, it doesn't use any of this. After the fact, it does this. After the fact, it does this. It says these values just for printing, actually. I'm so confused. But if I go like this, am I blind? Wait, the print was fucking it up. Okay, so the print was fucking it up. Okay, cheers. Okay, yes, that's a very easy problem. Why can't you print node dot write dot val? I thought that worked earlier. Write dot val is not valid. What about just node dot val? That valid? Node dot val is valid. What about print node dot val? Oh, it's an out of bounds error because if I did this exact same thing, I say like if node dot write dot val is not none, right? Then this should work. Right dot val is none, no attribute val. Is none? None type has no attribute val. So how would you? What was this doing? I guess you don't do. I guess you just have to do like a write val equals node dot write dot val if if there's a node dot write else none, right? And then you print the write val. Got him. Okay, that was very easy. By the way, I just had to get a little used to trees. Given the root of a binary tree, return its depth. That should be fucking easy. So this is just a depth of 3? I always thought, okay. I thought it always started at 0, but okay. So what is this? This is the depth first search, right? Oh, how do you do a DFS? I mean, you could also just do, I could do the exact same thing I did last time. Like find depth, pass through node, right? And then take that node and just say, like, um, if node is none, return node. I should also do this outside of this. if node is none, return node, return root, just return, and then I can just say like node dot, I can say find depth, node dot right, find depth, node dot left. The only thing I want though is I need a count of like how far one of these goes down. Right? I'm gonna use the bathroom real quick. I'll be right back. I'm back. Where were we? Oh yeah, recursion. Going down. I have to keep track. I forget how I did that in my last one. I think I just have to do like a I have to do like a return thing, right? Oh yeah, I can easily just do like a count variable, right? So when I call this in my actual thing, when I call find depth with the root and 0 on these, I can just do this with a count plus 1, count plus 1. And then can I do something? Isn't it like I can do this and then I just like return counts? I actually don't think this. That's not how this works. Right? I'm going down. Actually, what if I print? I'm back. Sorry, thought that came in. I wanted to see if I could print the node dot. Nope, nope. I wanted to see if I could print count. Sorry, came in again. I think I actually have to pass through 0, 0, and then this will have count right, count left. Oh, I don't know. Let's see if this even works. Invalid syntax. You are right about that. Wait, what? Oh. Node is not defined. Sorry, if root is none. Count left. Oh. Um. Oh no. Yeah. Forgot about that. Is find apps is not defined. Should be. Oh. But the expected return type is int. Oh. Return 0. Um. Why? Why wouldn't this work? So I originally call it with our root and initial counts. Find depth if node is none. Return 0. Otherwise, recursively call this, increasing the count on the right by going down the right side. And then keep doing that. Result equals this, print result. And then I kind of want to do like a return on this. Return count right, count left. Zero, a 0. Why? Uh, why? Why would this be 0? Why would this be 0? Node. Node dot right. Passing through, this would be 0, 0 the first time. And then we do it again. This would be 1 and this would be 0. And then I'd do it one more time. Well, actually, I guess these should be 1. Will this return 1, 1? Okay, it returns 1, 1. While node. How about while node dot right or node dot left? No. Wait. No, this would be fine. I don't know what's happening. I don't actually know why this wouldn't ever be increasing this. Like, shouldn't these just recursively exhaust? I don't get why. So no, give me this. Why did this even go away? Not having of code, tree traversal. Why is this not correctly returning the depths of both sides of a tree at their deepest? But like okay, so it's saying you should return the result of your recursion. But why? I thought it was like if you call a recursion, it's going to keep doing that exhaustively and then it'll just stop, right? You're not going to get to that return before that's the depth calculated for. Left depth and right depth equals find depth. There's no way this works. No, 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 no. What the fuck is this logic? What? There's no way this ever works. Bro, what? No, I want you. We're returning fucking zero. This will fix that error. But like, what do you mean? Left depth is equal to find depth at this. Return max of left depth. What does that even fucking mean? How is this finding the depth? All you're doing is recursively going through this. No? The left depth is equal to. I don't get this at fucking all. What? How is that ever finding depth? It looks like you just call the same function one layer down. It doesn't even keep track of a count. The depth of a binary tree is the number of edges along the longest path. How does the recursion track depth? Every time you make a recursive call, it essentially moves one level down. Yeah. All right, 3. Call find depth 3. Call find depth 9. Left child of 3. Since 9 has no children, we return 0 for both left and right. Therefore, it's 1. 20 right child of 3. I honestly still don't get it. But like, okay, yeah, I get this plus 1. I guess in my head, right? You could keep doing this, and then you could just like, but like, what is this? I don't understand. You're saying left depth is equal to the recursive call on node dot left. What is this ever returning when there's no, the return is a max of this and this? I mean, like, I mean, literally. No. I mean, obviously that doesn't work, but it's like, Oh my God, I don't get it. I actually just don't get what is happening here. I mean, maybe I just don't get it. It's so weird. Left of depth calls find depth on the left node. I understand all this, but how is this holding on? So like, okay, in my head, what you would need to do here is you need to keep a variable count. Like you keep going down and going down and going down, and so you do something where it's like what I was doing last time. I don't get it. Oh wait, it's because when you get down to that deep recursive call, it's returning just 0, 0 plus 1, and then when you go up a level from wherever you were the deepest, that return was 1 or like, oh, I get it now. Yeah, no, I get it. So it's saying um uh so if we have, wow, this is ugly. Like, let's say, oh my God, let's say we have this, right? I really scrolled all the way out. Can I like do this and just like shrink it down? Ah, beautiful. Okay. So like in this situation, right? We're saying we're saying, okay, we're going to call to this and to this, right? This is 0 and 0 in that max, right? And then 1, right? But we're not returning yet because we got to another recursive case. So we're not getting down to that return yet. So we go down to like this one, right? And this one. Those are those two recursive calls. And then we're like, oh, there's nothing down here. So we are going to do a return now, right? So we're going to say, we don't have a result for either side right now. So it's just 0, 0 plus 1. So both of these are going to return a +1, right? So the result of this iteration in this block is going to say 1, 1 on max and max. Sorry to pause for a second. It's going to return that on max and max, right? And then up here, that's just the +1 at that stage. And then down here, we get here, but then we also have another thing that goes. I wanted to like, actually, I guess this would be a better example. Is like, okay, we get down to like here, right? And there's nothing left. So its recursive calls are going to come back to here, and its recursive call is going to be, um, well, actually, it'll also have this. So this recursive call is going to have, I guess it's better to go down all the way. So this will be 0, 0, +1. This will be 0, 0, +1. So this is going to end up being, both sides are going to have 1, and so it's going to now this one is going to have 1, 1 +1 because these two are 1s, right? And so now this is going to have like a depth value of 2, so it's going to return 2. So then here, this is going to have this has no like children, so this is going to be a 0, 0 +1, right? So this is going to be a 1. So here is where you see it happen. It's a 1, 2 +1. I'm pretty sure, right? And then the max is 2, so we have a 2 +1, and so this is now 3, right? So now we have a 3. This is 0, 0 +1. So we have a 1, 3 +1. 3 is the max. So we come back here, and this receives a 4. And then because this was a 0, 0 +1 and a 0, 0 +1, then this is going to be a 1, 1 +1. So this will be 2. So this is going to come back as 2, 4 +1, 5. And then we had 1, 2, 3, 4, 5. And that's our depth. Right? Came in again. Yeah. I think that's pretty good. That makes sense. This tree stuff's fun. I like trees. I'm gonna have to get used to them though. This is a nice little introduction. Like these were definitely good introductory questions. I don't know. But like, so I'm guessing like every node structure is just defined like this, like how a linked list had a dot next and dot val. This is just the left and right dot val. I wonder if though, if there are questions that have multiple, like, do computer science, tree questions ever have more than left and right nodes? Am I going to kind of left and right node? Oh, I'm so stupid. It's a binary tree. So it's either it's a left. Okay, never mind. Der. Okay. Well, I have hit the 1 hour mark. I won't lie. So I want to wrap this up because we did 2 Leetcodes, and that's what I wanted to do. So, started work on trees. Learned about some recursive counting techniques and generally how to traverse a tree. Okay. Okay. So I will be back hopefully in the morning tomorrow. Um, yeah, hopefully we can do Advent of Code. I don't know if I want to do I probably should do yesterday's Advent of Code tomorrow. And then maybe I do both Advents of Code if I have time in the morning. I might do that. I might do both Advents of Code in the morning. And then we'll do the 2 part 2s I missed sometime next week. Yeah. And then Monday I'll probably only do one or two lead codes again in the morning, and then I have to go to the school for the final. Yeah. And then Tuesday we can finally start doing projects and like some cool stuff. So yeah, I will see you tomorrow morning, hopefully. Bye.